Hi, everyone. Welcome to our first video for week 4. This week, we're going to start talking about inferential statistics. We're going to begin that discussion with the process of statistical estimation. So estimation is the process of using sample data to estimate population parameters. There are two types of estimates that are commonly used in statistics. The first is called a point estimate, and the second is called an interval estimate. Point estimates are kind of what they sound like. They're a single value that we're using to estimate a population parameter. In general, the best point estimate for a population parameter is its equivalent sample statistic. For example, if we're trying to estimate a population mean, the best point estimate for that population mean would be the corresponding sample mean of a sample drawn from that population. We're also going to be using point estimates to estimate population standard deviations by using sample standard deviations. The other type of estimate is called an interval estimate. Interval estimates use a range of values to estimate a population parameter. So instead of saying, I think the population mean is approximately 70 inches, I'm going to say, I expect that the population mean is likely between 68 and 72 inches. The center of this range of values is the corresponding sample statistic. So if we're building an interval estimate for a population mean, the center of that range of values is going to be the sample mean. The margin of error is then added or subtracted to that sample statistic to create the range of values. The margin of error is primarily based on two things: the standard deviation, three things, sorry, typo, the sample size, and how confident we want to be that our interval contains the population parameter. So for standard deviation, the less variable the sample, or the less variable the population rather, the narrower our interval will be, because when the data is more closely clustered around that mean, our data is more predictable. And so we don't need quite as wide an interval for populations that have a small standard deviation. For sample size, the bigger our sample, the more confident we will be in our answer. So bigger samples usually require smaller intervals. With how confident we want to be, the more confident we want to be, the wider our range should be. And that's kind of like playing darts. If you want to be certain that you're going to hit the board with your dart, a bigger board is helpful. The smaller the board, the harder it is to get your dart on that board. Confidence intervals are the same thing. If we want to be certain that our population value is somewhere in this range of values, a wider range is better. So the more confident we want to be, the wider that range is going to get. Okay, if you have any questions, feel free to contact me. I've got office hours on Tuesday and Thursday. I'm also available via email and text message. Contact information is on Canvas. I hope you have a good week, and I'll see you in the next video.